My dear friends, welcome to Rajashekhar classes on applied data science with Python. This is lecture number 649. In this lecture, we will try to understand deep RNN. So, if you recall in MLPs, we first learn how to build one layer of MLPs and then we extended it to deep MLPs. Similarly, even in CNN, we learned how to build a convolutional layer and max pooling layer. Then we extended it by just layering one convolution, max pooling one after the other, and we build deep convolutional neural networks. Similarly, we can take RNN units. A simple RNN or LSTM or GRU, we can layer one on top of the other so that you will get a deep RNN. A deep RNN typically looks like this. I draw a simple diagram so that you will get a good idea about it. You have first layer. You have first layer of let me say this is, of course, this is first layer, and you have just zeros or random values here. You have your xi1, it generates some output, and it goes to xi2, again it goes to xi3, you have xi, let me say you have xi4, and even let me assume you have xi5, isn't it? Just see, you have xi5. Let me say this is layer 1 and this is input layer, this is time axis, isn't it? This is depth axis. This, let me assume this one is depth axis. If you have more and more layers one top of the other, it will be a deep RNN. Isn't it? These are time steps. First time step, at first time step you have xi1, at second step, a second time step you have xi2, third time step xi3, so on and so forth, isn't it? Each of these cells are LSTMs or GRUs or RNN. Again, a simple RNN cells are not used often as they don't learn long-term dependencies, isn't it? Simple RNN cells are not used as they don't learn long-term dependencies, isn't it? Most often you simply have LSTM units. You can simply have LSTM units or LSTM cells here. This could be a set of LSTM cells. You could have GRU cells, one on top of the other. The output of this, just see, the output of this will be input again to the same structure. That's important, isn't it? The output of this will be input to again same structure, is the same structure, continuous. This is your, I can say, layer 2. You can keep stacking one layer on top of the other. Actual structure of deep RNN is I can say actual structure of deep RNN is very problem specific, isn't it? Actual structure of deep RNN is very problem specific. Back propagation and forward propagations are very simple. In whichever direction your arrows are, your forward propagation happens. Forward propagation happens in the direction in this particular arrow, isn't it? That's what it says. Just see, your forward propagation happens in this particular direction. In similar manner, in reverse to that, your back propagation will occur. Your back propagation happens in this particular direction. That you have to understand, isn't it? In reverse direction, I can say back propagation will occur in reverse directions to forward propagation. Back propagation, I can say back propagation will occur both across the time and across the depth. If you just reverse the arrows, then you will get back propagation direction, isn't it? If you just flow in the direction of arrows, you will get forward prop. If you flow opposite direction, you will get back prop, isn't it? All the calculus and everything remains same, and nothing will change. Core concept of RNNs is the LSTM cells. That's important, isn't it? If you just flow in the direction of arrows, you will get your forward prop. If you just flow in the opposite direction, you will get back prop, isn't it? What it says, core concept of RNN is the LSTM cell or GRU cells. Those are the key concept. Rest of the structures are very similar to what we have seen in MLPs and CNNs. Nothing very fancy, nothing very different. The key things that you have to remember is that forward propagation happens in the forward direction, isn't it? Forward propagation happens in the forward direction and back propagation happens in the reverse direction to the arrow that we have in forward propagations. That's why these diagrams are very useful. If you don't have these arrows, it will super duper confusing, and how the back prop and forward prop are working, except that's how the forward prop and back prop are working, except that the core concepts are same. When we have a deep RNN, all of the machinery that we learn like dropout, like batch normalization, all these concepts are still valid even in the case of LSTMs and GRUs, just like the way they are valid in the case of CNNs. You have concepts like flatten, even you can have in deep RNNs. We will see some examples later in this chapter, real world examples of actually taking sentences of reviews of the movies, and we will take sentences of the reviews of the movies, and we will determine whether the review is positive or negative. Actually take reviews from I can say IMDb, which is a very popular website which has lots of reviews of movies. We will see an example so that all these dots, all these concepts are much more clearer for you. Structuring deep RNN is very similar to deep MLPs or deep CNN, except that the core units now LSTMs or GRU units. I request you to go through this lecture. If you have any difficulty, please keep a comment. Thank you very much.